Okay, so we're going to look at evaluating logarithms. Okay, on your notes packet it says change of base and solving logarithms. This is evaluating. Okay, so in the last unit we looked at evaluating just by using mental math. So for instance here, log base 3 of 9. If I wanted to evaluate that, I would set it equal to x. I would convert, so 3 to the x power is equal to 9. Which means x would have to be 2, because logarithms are exponents. Okay, so 3 squared would equal 9, so x would have to be 2. Okay, we could do the same thing if we were going down with a number. So for instance here, still set it equal to x. I would get 16 to the x power is equal to 4. Well, if I want to make the number smaller, reduce the number, then I use fractions, because the square root of 16 would equal to 4. Well, square root as an exponent is 1/2. Okay, cubed root would be 1/3, fourth root would be 1/4, so on and so forth. So the square root of 16 equals 4. Okay, well now what do we do with something like this? Still set it equal to x. I would get 8 to the x power is equal to 24. Okay, 8 to the x power equals 24. There is no number that I can raise, at least not a pretty number anyway, that I can raise 8 to get 24, okay? Because 8 to the first is 8. Not big enough, so you go to the next number, 8 squared. Well, now I'm at 64, so it's somewhere between 1 and 2. Okay, we just don't know where exactly that's at, so it's going to be some kind of a fraction. So whenever you get this, where you can't figure out what x is mentally, we go to the change of base formula. Okay, the change of base formula. So the change of base formula says as such: A, B, and C are positive real numbers, and B nor C is 1. Remember, we don't work with bases of 1 with logarithms. Then the log base B of A equals the log of A divided by the log of B. Okay, now you might be wondering where the C's went. Technically, this is log base C of A over log base B of, or C of B. I could change my logarithm to any base that I want to, as long as they're the same. Okay, the only reason why we don't write it in this formula here is because what I want to change it to is base 10, which is what this is. Log of A means log base 10 of A. Why change it to base 10? Well, because base 10 is the only thing your calculator does. There's two bases that your calculator can do. It can use a base 10, which is the log button. Okay, so if I look at my calculator here, okay, and you look at this, I have the log button. Okay, I know mine's kind of faded, but the log button, that's actually a base 10. Okay, so when you hit log on your calculator, it means base 10. I also have the natural log button, the LN button, which sits right below the log, and that's a base E. So that's the only two bases that your calculator does, base 10 or base E. So when I do a change of base, since we now have calculators we can use, I'm going to use base 10. Okay, so instead of doing log base 2 of A, I'm not going to do that. I'm going to use log base 10, and that way I can plug it into my calculator. So what does that look like? Okay, notice here, base goes on bottom. Okay, base goes on bottom. So when I split this, log base 8 of 24 means log of 24 divided by the log of 8. Okay, this is different than when we did subtraction and stuff like that and changed it to division. Here I do a log on both. Okay, when it splits, just like the property says, log base B of A means log of A over log of B. So when it splits, they both get a log. Okay, and they're log base 10. So now I can plug that into my calculator. Okay, so take your calculator and go log of 24. Okay, because we're trying to do log of 24 over log of 8. You have to close these parentheses. Otherwise, your answer is going to be incorrect. Okay, so then divided by the log of 8. Again, close those parentheses. Without closing those parentheses, then you're saying log of 24 divided by log 8. We want the log of 24 in that divided by log 8. You have to remember that in math, parentheses are kind of like commas or periods in a sentence, okay? That ends that thought. So it's a log of just the 24 in that thought, then divided by log of 8 in that thought. So keep that in mind if you're an English-minded person. Parentheses act kind of like the periods in a sentence, okay? That's the end of that thought right there, okay? So hit enter, and we get an approximation. Now we're going to round these to 2 decimal spots. That's what we did in class. I believe your homework might be to 4 decimals. Okay, but in class we did round to 2 decimals, so that's what we're going to do here. Okay, so if I'm going to round to 2 decimals, then I go to the third decimal. If it's 5 and higher, then I round up on my second decimal. If it's 4 or lower, then you leave it alone. I believe the saying is 4 or less, let it rest. Okay? So here, we're going to have approximately 1.53. Okay? And that's what those squiggly little lines are. Instead of equal signs, and let me write it a little bit bigger and prettier. Okay? If you see these ever, okay, that means instead of equal, it means approximate. Okay? That just tells me that it's been rounded. So instead of, this isn't an exact number. It's not 1.53 exactly. It's actually 1.528, blah, 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 blah. Okay? So we use the approximate to say, hey, I did round this, just so that somebody else looking at it knows. Okay? So same thing here. Okay? Log of 3 divided by the log of 5. Okay, log of 3 divided by the log of 5, which is going to be an approximate. Okay, so again, you go log 3, close, divided by log 5, close, and that's going to give me approximately 0.68. Okay, approximately 0.68 is my answer there. Now you have the on your own. Okay, you can hit pause if you need to. You could probably have this done before I even finish talking. Okay. You're going to do the split. When you're doing your homework, I do require work, and this is the work that I need to see. Okay, I need to see you do the change of base formula. Okay, so show me the log 72 over the log 9, especially on your test, because if you accidentally forget that parentheses and you just give me a decimal, I can't give you any partial credit. If you at least show the change of base and then you get it wrong, then I'll know that you just plugged it into your calculator incorrectly. So please, please, show that change of base. On the homework you have to, or you won't get credit there either, because I want to see the work. Okay, so log 72 divided by log 9. Okay, closing parentheses, doing good. What? It's going to be approximately 1.95. Okay, because the 6, that's my third number. It's bigger than 5, so we're going to round the 4 up to 5. So 1.95. Alright, so that's those. Now, C and D are equally, they're kind of the same sort of idea, okay, and a lot of people miss this, and there's really no reason to. I don't even have to do a change of base here. I could, but I don't have to, because this is already base 10. Well, that is what my calculator does. So if I just go to my calculator, and I plug in log 5, well, that's what my calculator does. Log 5, it's base 10, so you get approximately 0.70. Okay, 0.70, because when I round up here, my 8 would round my 9 up, so this becomes 0.70 instead of 69. Okay, so 0.70, same thing with the natural log. This just says natural log 6. Don't let that confuse you. We have a natural log button. It's right underneath the log. Okay, it's right underneath the log, right here. So you hit the natural log. I know you can't really read mine, but yours is right underneath the log. Just hit natural log of 6. Okay, and you should get natural log of 6 is 1.79. Okay, 1.79. So 1.79 is my approximation. Okay, don't round that up, because you go to the third number. The third number is 1, so the 9 isn't going to round. Okay, again, do that last one there, the on your own. It's a natural log of 3.5. Okay, you can probably get that done pretty quickly. Okay, so natural log of 3.5 is just approximately 1.25. Okay, so if you're having issues, if you're not getting these answers, make sure you're watching your parentheses. Okay, here you didn't really even need to close the parentheses because there's only one thing. But when you have more than one thing, you have to close those parentheses up. So approximately 1.25 is what you should have there. Now, solving. Okay, this is just how you enter stuff into the calculator, is what we just looked at. But what we want to be able to do is we want to be able to solve anything that has exponents, anything that has logarithms. Okay, we want to be able to do word problems, which we'll get to in this unit. And so we need to be able to solve for x when x sits up in the exponent spot. Okay, because that's not something we've really done a whole lot of. So we're going to do that using the logarithm property of equality. Okay, so with the log property, what it says is if I have log base b of a equal to the log base b of c, well then a and c have to be equal to each other. Okay, if my log and my bases are both the same, a and c has to be equal to each other. So an example of that would be if I had log base 2 of 5 equal to log base 2 of a, okay, well 5 and a have to be the same. That's the only way that makes sense, is if a is also 5. Log base 2 of 5 has to be equal to log base 2 of 5. So a would have to equal 5. So we're going to do that concept, but the way we're going to use it is that we're going to be able to take the log of both sides. Because we're going to look at stuff that doesn't have logarithms, and we're going to take the log of both sides. Okay, so taking the log of both sides is just like square rooting both sides or squaring both sides. It's the same sort of concept. What I do to one side, I do to the other. Okay, so this is not a conversion. This is actually using the property. So here, I have a variable and an exponent. And there's no way to just look at it and say 3 raised to some power equals 7. It's going to be some decimal. Okay, so we can't do anything with that at the moment. So what we need to do is get that variable down. The way you get a variable down is by using the power property. Okay, because if I have the log base b of a to the r power, that r can come down to the front. Well, the only way to do that is if I have a logarithm. I can't just drop it to the front. That doesn't work. I have to have a log. So what we're going to do is take the log of both sides. So literally just going to write log in front of both sides, so log of 7. This is not a conversion. I'm not doing the log base 3 of 7 equals 2x. That's something different. You can do it that way, and I can show it to you in a little bit. Okay, but that's not what we're doing. Here we're just doing log of both sides. Okay, by doing that, that allows me to take this exponent and drop it to the front. So now I've got 2x log 3 equals log 7. Okay, notice I'm using base 10 logs so I can do them in my calculator. So now, I've got 2 times x times the log of 3. Well, how do I get rid of multiplication? Divide. Okay, opposite operation. So we're going to divide by everything I want to move. 2 log 3. Same thing to both sides. As long as I do it to both sides, then it's going to still be equal. Okay, so I divided this, so here goes my 2, there goes my log 3's. So I've got x is equal to log 7 divided by 2 log 3. And this is my exact answer. Okay, so if they ask for an exact answer, here it is. Okay, I can't plug it in and round because that's not exact anymore. This is an exact answer. Now when they want the approximate, because you're going to have to be able to do both, okay, we're going to plug it in a calculator. Now you have to be very careful again with your calculator here, because you're going to have different answers if you don't enter it in correctly. So I want to do log 7, close parentheses, divided by. Now in math in general, not just with logarithms, but always in math, when I'm using my calculator, if I want to divide more than one thing, I have to use my parentheses. If I don't parentheses the bottom, I'm going to get a different answer. So you have to open a parenthesis and put my entire denominator in there. So I get 2 log 3. Okay, this first parenthesis closes the log. So I've got log 3, close that. And then a second parenthesis to close the denominator. So the whole thing is wrapped in parentheses, 2 log 3. So now it's log 7 divided by this whole thing. Okay, without that set of parentheses, the only thing it would divide by is the 2. And I'm just going to show it to you to show you the different answers. So let's say I just did log 7 divided by 2 log 3. The only thing my calculator is dividing by here is that 2, and then it's going to multiply by 3. You'll see the different answers. Okay, so 0.201. Okay, so you have to be careful. That whole denominator must be in a set of parentheses. So this is my correct answer, which was 0.89. So you should have gotten approximately 0.89 as your answer. Alright, so B. Okay, again, there's multiple ways that you can do these. I'm just going to take you through what I figure is the easiest. So here, it's 5 times 2 to the x plus 3, and that's equal to 50. Okay, well, if I take the log of both sides right now, then I'm going to have the log of all of this. Okay, well, and then I have the log of multiplied arguments by property. Then I'd have to split that into log 5 plus log 2 to the x minus 3, and then drop that down. Doable, but then I have more steps. Instead, since I have this extra 5 out front, what I want to do is divide it over first. So I get 2 to the x plus 3 is equal to 10. Okay, so now I've gotten rid of that 5 out front. Now notice I didn't do it here because I didn't have an extra number out front. All I had was my base. I can't divide out my base. That's not allowed. Okay? You have to have your base there. You can't just pretend like that exponent doesn't exist. But that's different from this next one. I've got that extra 5 out front. I still have my base, which is 2 here. Okay, so I still left that so that I have something with my exponent, but I can get rid of that extra 5 out front. So divide that out, and now I've got a variable in the exponent, so I need to get rid of it. So we're going to take the log of both sides. So log of 2 to the x plus 3 is equal to the log of 10. Okay, take the exponent, drop it to the front. Make sure you use your parentheses here. So you get x plus 3 log 2 is equal to log 10. Now I need to solve for x. I need it by itself, and you have to be careful here. This is x plus 3. I had to use parentheses because when I divide, I can't divide by 3 because this isn't times 3, it's plus 3. Okay, here it was 2 times x times log 3, so we divided by 2 and log 3. But here this is x plus 3 times log 2. So when we divide, we can only divide out the multiplication. So just the log 2. Okay, so now the log 2's are gone. Now I've got x plus 3 is log 10 over log 2. Okay, well now how do I get rid of a plus 3? I subtract 3. So I'm going to minus 3 from both sides. So x is equal to log 10 over log 2 minus 3. Okay, so this is my exact answer. Plug that into the calculator and you can find your approximate. So again, watch your parentheses here. Okay, so I'm going to go log 10 divided by log 2. And I'm going to go ahead and hit enter and then minus 3. Just because I feel more comfortable doing it that way. So I did my division part first and then I subtracted 3. So I should get x as approximately 0.32. Okay, so that would be my answer. Alright, there's an on your own. I highly suggest you hit pause and try this one. Okay, hit pause. It's going to take you a second to figure it out. So hit pause, come back, see if you get the same answer as me. I'm going to keep on going because you can always pause me. Okay, so here I don't have a number out front, so I'm going to go straight to the logarithm because I got to bring that x minus 3 down. I can't solve for x as long as it's in the exponent spot. So I'm going to take the log of both sides. So log of 4 to the x minus 3 is equal to the log of 13. That allows me to bring my x minus 3 down in parentheses. Okay, that whole exponent has to come down in parentheses. So log 4 is log 13. Divide by the log 4. Again, can't divide by the negative 3 because that's x minus 3, so that's not allowed. Okay, so log 4 goes away. I've got x minus 3 is equal to log 13 over log 4 plus 3 to the end. Okay, so that's my exact answer. X is log 13 divided by log 4 plus 3. Find your approximate. Use your calculator. Log 13 divided by log 4 and then plus 3. So you should get approximately 4.85. Okay, so x is approximately 4.85. Okay, if you need to, go back, print out a new paper of those, try those again, see if you can get them correct. Okay, write them on a separate sheet of paper, see if you can go through and do them. Okay, this is going to be super important. You're going to see a whole lot of that in this particular unit. Alright, so the same is going to hold true for natural logs. Now here's my hint to you. When you see E, immediately switch your brain over to natural logs. Okay, when we see E, we're not going to use the log anymore. We're going to use the natural log because it's going to make our life easier. Okay, so here, I'm going to do it the same way that I did these. I have a base raised to an exponent, and that exponent contains my variable. I want it down. I can't just take it down, so I have to use that natural log. Okay, instead of using the log of both sides, I'm going to do the natural log of both sides. Here's why. Okay, so the exponent's going to fall to the front now, so I get 3x natural log of e equal to natural log of 14. Okay, well, what's the natural log of e? Okay, you can actually do that in your calculator if you're not sure. You should know it because it's in the last unit. But natural log e sits over here underneath the divide, so hit second divide. okay? It's right here. Hit second divide. You see that little e there. Natural log v is just 1. So essentially, because it's going to become 3x times 1, so really that just goes away. And you get 3x is equal to the natural log of 14. Okay, which is nice, because then how do I solve for x? Well, this is 3 times x, so to get rid of times, you divide. So I get x is equal to the natural log of 14. That's my exact. And then approximate, plug it into your calculator. Okay, so now instead of the log, we use the natural log button of 14, close parentheses, divided by 3, and you get 0.88. So 0.88 is my approximation there. Okay, so same sort of thing happens with b. Okay, only be careful here. This is 3 times e to the x minus 2 equals 12. So just like up here, I have that extra number there. Okay, e is my base. E is what has an exponent on it, not the 3. The 3 has no exponent, just the e does. Okay, so we're going to divide both sides by 3. So you get e to the x minus 2 equals 4. Now if I want to bring that exponent down, then I have to take the natural log of both sides. Okay, so the natural log, that x minus 2 can come down in front now. Natural log of v is equal to the natural log of 4. The natural log of v is just 1. So 1 times anything is itself, so it just goes away. So I get x minus 2 is equal to the natural log of 4 plus 2. So x is equal to the natural log of 4 plus 2. No, you cannot change that to the natural log of 6. This is the natural log of 4. This number is not a natural log at all. It's just plus 2. So it's natural log of 4 plus 2. So that you plug into your calculator. Okay, so we're going to plug that into our calculator there. We get the natural log of 4, close parenthesis, plus 2 equals 3.39. It's going to round up. So 3.39 is your approximate answer there. 3.39. Okay, so here, do the on your own. Okay, hit pause, come back. Really hit pause though, because I can't stress that enough. When you do your homework, make sure you're working all the way through the homework, because a lot of these look a little bit different, and the more you do of them, the easier they become. So hit pause, come back, see if you can get the same answer as me. Here we go. Divide by 4 first. So I get e to the 5x is equal to 5. Okay, because that was an extra one. I didn't need that 4 there. The e has the exponent. So now I've got e to 5x. I need to bring it down. To do that, I take the natural log. Again, I'm using natural log because I have an e here. Okay, anytime you see e, start using the natural log instead of the log. So 5x, natural log of v is equal to the natural log of 5. Okay, well the natural log of v is just 1, it goes away. 5x is equal to the natural log of 5. I want x by itself, so we divide by 5. Okay, so x equals, helps if I can write it where you see it, the natural log of 5 over 5. You can't cancel those. This is the natural log of 5. This is just 5. One's inside the log, one's not. Those are two very different kinds of 5s. Okay, so you can't cancel them out. Natural log of 5 over 5. Plug that into your calculator. So natural log of 5, close parenthesis, divided by 5 is 0.32. So you should get 0.32 as your approximation. Alright, so now moving on. We also have to use our properties. Okay? We also have to be able to use those properties. So, for instance here, these are our 3 properties from the last unit. So when I have, this is the product property. If I'm adding 2 logarithms with the same base, then I multiply the arguments together. Okay, if I'm subtracting the 2 properties, okay, 2 logarithms with the same base, this quotient property, subtracting the 2 arguments, okay, and then I'm going to divide those arguments. And if I have an exponent on an argument, then that can come down to the front. Okay, so, and we've already used this one a lot. These 2 we haven't really yet. Now there are multiple ways you can go about solving these. Okay, I could do a change of base here and just take that value and subtract it over here, because this is actually a number, right? And then I can subtract that over here, and then I can go 4 raised to that number equals x and figure out what x is. Okay? Or, and you will have to do that, if you have different bases, you will have to do that method. It shows up in your homework. Okay, so there is one where the bases are different, and you'll have to do that there. Now, okay, otherwise, if my bases are the same, then I can use my property. So I've got log base 4 of 8 plus the log base 4 of x. That gives me log base 4 of 8 times x. Notice there's only one log now. I'm writing it as a single log. So that's the first step, is to write as a single log. Okay, write it as a single log. Okay, from there, well, I can't take the log on both sides because then I got a log of a log. That's horrible. Don't do that. Okay, and convert it. Okay, convert it. Convert it to exponential. That's that snail thing that we did in the last unit. Okay, the snail thing. So convert. So 4 squared equals 8x. Well, that should be pretty simple. 4 squared is 16. Divide by 8. And I get x is equal to 2. Okay, x is equal to 2. So 3 is solve. There's technically 4 steps to this because you also have to check. Okay, so when I plug it back in, you don't really even have to check fully. All I really want you to look for is to make sure that you're not taking the log of a negative. Okay, we can't take the log of negative. So here, when I plug it in, I would have the log of 2. That's fine. It's a positive. Okay, I can have negative answers. I just can't take the log of a negative. They're not in the domain. They're imaginary numbers. Okay, and I'll show you one of those in just a second. So for instance here, log base 2 of x plus log base 2 of x minus 1. Okay, well, the easiest way to go about this is, since I'm adding two logarithms with the same base, I can multiply. So I would get log base 2 of x times x minus 1 equals 1. Well, distribute there, so you get log base 2 of x squared minus x equals 1. Okay, well, that's step 1. I wrote it as a single logarithm. Now convert. So 2 to the first power, which is just 2, equals x squared minus x. Well, how do I do that? Okay, anytime I have an x squared and an x, I have to use factoring. Okay, I'm either going to have to factor, quadratic formula, anything like that. But this is a quadratic. If I just had an x squared, I could square root both sides. But I can't square root with this x there because my x is going to get stuck under a square root somewhere, and that doesn't work. So I have to set it to equal to 0, so we're going to subtract the 2 over. Okay, so I minus 2 over to here. X squared minus x minus 2 equals 0. And then you have to target product, target sum. So target product is negative 2. Target sum is negative 1. Okay, multiply the outsides to get negative 2. Inside gives me negative 1. So my two numbers are going to be negative 2 and positive 1, because that multiplies to negative 2. Negative 2 plus 1 adds to negative 1. So I get x minus 2. I get x plus 1. That's all equal to 0. Set each one equal to 0, so x minus 2 equals 0, so add the 2 over, x is equal to 2. X plus 1 equals 0, subtract the 1 over, x is equal to negative 1. Okay, so again, you have to check for extraneous. This is the solve part. We're there. Check for extraneous. So, plug the 2 back into the original. I get the log of 2, that's positive, that's fine. 2 minus 1, that's positive, that's fine. Okay, so x equals 2 works. Negative 1, so that'd be the log base 2 of negative 1. We don't even care about the base or anything. I'm taking the log of a negative number. That does not work. Okay, that does not work. So this is going to be extraneous. And you can write doesn't work, you can write no, I don't really care how you identify it, as long as you identify that this does not work. The extraneous solution does not work, whatever the case may be. Just identify that this does not work. Okay, so that's adding them. So now I've got one where I'm subtracting. Okay, I'm subtracting two logarithms. It's log of this minus the log of this. Okay, that plus doesn't matter because that's inside of the log. I'm talking about subtracting two different logs. So this minus this. So we do that as division. That's what the property says. So log of x plus 2 divided by x equals 2. Written as a single log. Done. Second step, convert. Remember, when there is no base specified, we always assume it to be 10. So this is going to be 10 squared is x plus 2 over x. So 100 is equal to x plus 2 over x. Now your Algebra 2 skills are definitely going to be tried here. Okay? If I want to get an x off the bottom, because I can't do anything with it in the bottom, that doesn't work. So I have to get rid of the bottom by multiplying by x. Now a lot of people are distributing up here, but you can't do that. The whole purpose of this x is to cancel with this one. So those two go together. Okay, that's the whole point, was to multiply by x so that those two cancel. So I don't distribute and cancel. That would be, I'd need two of those. Okay, so we've got 100x equals to x plus 2. Well, what do I do from there? I want to get all of my x's on one side, all of my numbers on the other. Okay, so I've got an x here, so I'm going to subtract it over. This is x plus 2, so if I minus x, okay, x minus x is 0. 100x minus x gives me 99x's, okay, which is equal to 2. Now divide by 99, and that's going to be my exact answer. So x is equal to 2/99. And then if I approximate that, you just divide 2 divided by 99, and that's going to give me 0.02. Okay? It is repeating, but we're rounding to 2 decimal points, so I'm going to stop there, 0.02. So that's the end of that one. Now the next one, it's the exact same thing, only they say natural log now. But the same properties still apply. So natural log of 3 minus the natural log of this. Minus means divide. So we get natural log of 3 over x minus 1 equals 0. Okay? Well, what is the base of a natural log? Okay, the base of a natural log, and if you need to write it down again, this is last unit, but okay, the base of a natural log is e. Okay, the base of a natural log is e. So this, when I go to convert, means e to the 0 power equals 3 over x minus 1. E to the 0 is 3 over x minus 1. Well, what's e to the 0? What's everything to the 0? Just 1. So we get 3 over x minus 1. Again, if I want to get rid of the x minus 1 on bottom, because I can't solve with it down there, can't do anything with it down there, so we got to move it to the top. Those cancel. So 1 times x minus 1 is just x minus 1. Add your 1 over x is equal to 4. Okay, double check it. When I plug it in, 4 minus 1 is 3. Okay, so it's going to be a positive number. We don't really care what it is as long as it's positive. Alright, so x equals 4 is the answer there. There's the last on your own for this section. Hit the pause button, give it a shot, see if you can get the same answer. Here we go. Okay, I'm going to put them together. They've got the same base, so it becomes x squared plus 6x. Notice I use my parentheses. Without those parentheses, it's wrong. Otherwise, the only thing in the log is the x squared, and we don't want that. Okay, so make sure you have your parentheses there. That's all equal to 2. That is now a single logarithm. Let's convert it. Snail. It's a really big fat snail shell. That's hard to say. Snail shell. 4 squared is equal to all this stuff. X squared plus 6x. That's why you have to have those parentheses. Okay, because it's not just the x squared, it's that whole thing. Well, that means 16 is equal to x squared plus 6x. What do I do with that? I've got an x squared and an x, which means I'm going to have to factor. Okay? Put this thing in standard form. Here we go. Minus the 16, so I get x squared plus 6x minus 16 equals 0. Okay? Target product, target sum. Target product, negative 16. Target sum, positive 6. Remember, target product's just the outsides multiply together. Target sum is just the inside. Okay? So two numbers that multiply to negative 18 and add to 6. Well, 8 and negative 2 multiplies to negative 16. 8 minus 2 is positive 6. So 8 and negative 2. Okay, I'm going to come up here. So I get x plus 8 and x minus 2 equals 0. We'll solve. So x plus 8 equals 0. So x is equal to negative 8. X minus 2 is equal to 0, so x is equal to positive 2. Check them. You can't just leave it like that. When I plug back into the original, Log base 4 of negative 8. That's already got a log of a negative. Can't be done. Extraneous. Okay, 2. Log of 2. That's good. 2 plus 6 is 8. That's good. They're both positive, so x equals 2 is an answer. Okay, negative 8 is extraneous. And that is your evaluating logarithms.